Alright, so today we are going to look at this problem. It's a hard problem, and it's I think from the recent week biweekly contest. I think it was 174. I could be wrong. The question states that we are given integers, array of integers, nums, and this nums, it's not binary. It can be any value, um, and we are given an integer k, and we are asked to find all the sub-arrays which if we do a AND operation among the elements inside the subarray, then we get the number as the result as equal to k. So it's if you know bitwise operation, we have a popular function or rule inside that. That is, if we do a AND operation between two numbers, the resultant number, if we do an AND operation, suppose between these two numbers, what is 0? 0, 0, 1. This is 0, 1, 0. Here, if we do AND operation, the answer is always going to be less than the two numbers that we AND. Or it can be equal to one of the numbers, but it's always going to be less. So that is the rule that we are going to use to solve this problem. How we are going to use that? So if suppose I take this example, 1, 2, 3, right? Here, if I move from this point and k is equal to 2. So if I want to know that 1, uh, can it be a candidate for a subarray? No, it cannot be a candidate because this is already 1, right? So the result, if we add it to any other number, whatever it may be, the result is always going to be less than 2, right? That's why 1 cannot be a candidate. So what can be a candidate? Then we see 2 or 3. These two can be a candidate. Why? Because if you see, zero, 2 or actually 3, because two equal numbers, if you add it, then you get that same number, right? So I'm not taking that. I'm taking 3, and if I add it with k, just to see if it's giving me the value as k itself. Why k? Because if it's going to be anything else, like any other number rather than k, then basically what we are doing when we are doing this AND operation is we are unsetting the 0 bits wherever k is 0. Right? This will become 0. This is already 0. But here, when we are setting the bit when k is 1, if this is 0, then that case this cannot be a candidate. But this is 1, right? So in that case, this will come out to be k. It's always going to be the case. So if I have something like a bigger number like 0, 1, 0, 1, 1, 1, 0, 0. Suppose this is the number, this is k, and I have some other number like randomly 1, 1, 1, 1, 1, suppose 0, 1. Now all the zeros will eventually make the ones which needs to be 0, 0, right? So this will be 0, this will be 1, right? This will be 0, this will be 1, this will be 1, this will be 0, this will be 1, sorry, 0. So it eventually became equal to k. So this is a property and it's a useful property in other bit manipulation questions as well. And we are going to use that to solve this problem. So like I told here, I want to find which number is the candidate for that subarray. So I take this number, I AND it with 2. I see this is going to be 0, I think. That's lesser. I am not going to take that. It's not equal to 2, that's why I'm not going to take this number as the candidate. And similarly, I mean, I can store the previous previous to this, suppose I'm here, previous to this, whatever and values we have occupied till this point. I mean, if they were valid, if they were not valid, then my map, my storage will be 0. I mean, it will be empty. So if I have a map, I can store in a map, I can store in a, uh, 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 if the numbers were short, smaller, then I could have used a vector, but since it's very large, it's better to have a map. So inside map, I'm going to store, currently it's empty, and here I see I is 1 is not a candidate, and move forward. Now I see 2 is a candidate because 2 and 2 is equal to 2. So I add 2 and I keep the count. Suppose there were another 2, and that should also be counted. They can be duplicates. So I see that this is also a 2. Now I want this 2, this 2, as well as the AND of these 2 inside my counter, inside whatever I'm storing, right, till this point, and inside my answer as well. So I have an answer. Currently, uh, it's 1. Why 1? Because I already have a map. Now I have 2. So in that case, I have not cleared the map because I didn't find something like 1 in between. If I would have, then I would have cleared the map. But now I have found 2, which is also valid. In that case, I should increase my answer or increase my map to 2, right? And I should add, so this 1 when I added, this was actually, if this was actually, this 1 that I added in the answer, this was nothing but map of k, which was 2, right? This was the thing that I did. Now I'm here, I'm increasing the count because this is still valid, and this time I will, answer was 1 at this point. Now I will do something like this map of k equal to 2, which is what? 2. So I add 1 plus 2, that is 3. And 3 is the answer because this I can take, this I can take, this I can take, 3. Now if I would have encountered 1 here, then I would have cleared the map. I would have cleared the map. Then map will be this. I will check that 1 is not valid. So I won't add. I'll move forward. Now I see map is, I mean, this is valid because 3 and 2 is equal to 2. This is valid. But before that, I have not encountered any of the subarrays that it would be possible till this point. There would be here, but we have a broken pipe rate. We can't continue that subarray. So we have cleared the map. Now we add 3. But can we add 3? No, because I'm going to add only the map of k, which is not 3, which is 0. 2 is 0. That's not present. So that's how we are going to solve this problem. Let's code it. We are going to have a long answer equal to 0. We are going to have a map. I'm going to use 2 maps, one a global map and one, I mean, alternatively, I'll clear one map and give it to the other at the end of the loop. So let's see, you understand when I code it. This is map 1 and this is map 2 I will iterate. I will check if nums of I and k, if it's equal to k, basically I'm doing this part. If it is, then what should I do? Then I should keep this map inside. You'll see why, because I'm clearing this map every time I iterate, and this is the map that I'm keeping the count of my previous subarrays, right? So I'll at the end give this map value to this MP1. Alright. So if I encounter such number which is potentially a candidate, then uh, I add that number. Alright. I move through all the previous MP1 values, previous subarrays answers, which subarrays that was possible earlier. And that I can do is by traversing the MP1 that will give me two values, MP1, which is basically n, suppose, and count. But wait, here I am going to add MP, add the values MP2 with what? With n. See this very carefully. This is somewhere you can uh, get confused. And nums of I plus equal to count. So basically what I'm doing here is I'm having the numbers and their counts, right, of the previous subarrays. So I'm have to concatenate. I'm concatenating the ands, right? So I'm going to concatenate n with the current number, and I'm going to increase its count, whatever it is from. Like if it's zero, then fine. If it's having some previous values, then that is good enough. So here I had previous two as one, and I did and with it I edited this individually first here. And I did a and with the previous value that was 2 as well. This will add to 2 and the count will become uh, 3. The count will become 2. Alright, here I'm going to move out. I'm going to add the result or the answer with what? NP2 of K, right? And I'm going to uh, come out and give NP1 to NP2. So I think that's it. Let's see if this works. Oh, this should be this. Right. Yeah, this works. The time complexity is O of n. The implementation is easier, but the explaining part is a little bit. It can be confusing if you haven't solved much of bit manipulation problems. So the space complexity will be O of the space complexity will be O of 1, I think, I believe, because map is going to store, if you see what can be the maximum value. Maximum value can be 10 to the power 9. 10 to the power 9 value can have maximum of I think 29 bits, 30 bits. I think probably less than 32 bits. So I think the map will be maximum having a value of, I mean, number of elements will be max 32, or probably lesser. So this will be O of n, O of 1 in terms of space complexity. Right?